Hi, I'm Chris Grove, Technology Evangelist here at Nozomi Networks. Thank you for joining us today for our webinar where we'll discuss smart grids, securing encrypted communications. Joining me today from Nozomi Networks Labs is Yanis Stavro, one of our super talented security researchers. Say hello, Yanis.
Hello, everyone. I am a member of the Nozomi Network Security Research Team. My role is to support the team with protocol reversing and cyber threat analysis, and I also explore various research projects in the OT field, like encryption and threat modeling.
Excellent. So before we begin, as a reminder, please feel free to submit any questions into the chat, and we'll try our best to answer as many as possible live during today's session. So society is able to function and survive partially due to an amazing electrical infrastructure that's comprised of, in the US alone, 9,200 electrical generating facilities, 600,000 miles of transmission lines, and that delivers more than 1.2 million megawatts of power. When you add in all the other nations of the world, the size and scope of our power grid becomes apparent, and so does the challenge to keep it up and running efficiently and securely. To accomplish this, more and more computing resources are being added, and even more network connectivity. These smart grids are our best hope to obtain the necessary operational efficiencies and bidirectional communications we'll need moving into the future. But the more dependent we become on these technologies, the greater the risks. The threats can range from nation-state attackers conducting espionage and sabotage, to hackers, ransomware, viruses, cyber terrorists, and cyber activists. Among many other mitigation tactics, encryption can help with eavesdropping, preventing playback and spoofing, and helps detect intrusions, just to name a few of the cybersecurity benefits. On the surface, it sounds like a no-brainer. Encrypt everything. However, it's just not that simple. As you'll see in today's webinar, combining regulations with solving cybersecurity issues can be a challenge. Navigating between things like adherence to IEC 62351, the overlap with IEC 61850, encrypting industrial control protocols like Goose, and at the same time keeping the systems up and not introducing latency or other issues is the challenge that grid operators face, and what we're here today to discuss. So without further ado, let's set sail. Yanis, this is a really exciting and important topic. Where do you think we should begin to talk about this? How do we peel this apart?
So let's start with talk generally about encryption and where exactly we are going to explore encryption in the OT environment. And basically, encryption provides the property of confidentiality in communications. And when we're referring to the OT field, we refer to the lowest levels of the Purdue model, basically the field devices, PLCs with PLCs, actuators, sensors. Basically, all these devices communicate with, in the majority of them, without encrypted communication. In the higher levels, you can, in the SCADA infrastructure, you can have OPC-UA that has encryption. But it's a common practice that in the lower levels, we don't see any encryption whatsoever. Mm-hmm. And this is interesting because as an attacker, I have the perspective that I want to gain as much information as I want, especially if I'm an APT. I would like ideally to be in a factory and record the traffic, see the important interaction with the PLCs, understand the process. Even better if I get some PLC code, get downloaded, and then tailor my attack according to my target. So it's a topic that has some discussion of it, if it's important or not on the OT field. But from an attacker's perspective, there is a lot of value to understand what is happening in the process.
Right.
So as a first point, we'll discuss why there is no encryption. Because I said there is no encryption in the OT field, and the majority of the devices do not use encrypted protocols. So there are a lot of challenges, and basically the first challenge is the inheritance that we have. When the Ethernet technology was introduced to this kind of fields, security was not something that was important at that point. The key features that everyone was looking for was functionality and safety. We wanted the operation to be working and to not endanger human lives. So at that point, they integrated internet and get the benefits, but they didn't think, what if this technology broadcasts the information to eavesdropper or evil actors? So that's one reason. The other reason is more protocol specific and has to do with the OT protocols. Basically, there are some OT protocols that they cannot afford encryption whatsoever. I can give you an example from the grid industry, which is the Goose protocol. Goose is a protocol that is used to power stations and is going to be used in case if you have a power outage to cut the circuit and stop the problem from expanding. And there are strict timing limitations by using the Goose protocol. It's something like 4 milliseconds. This is the upper limit that is required for you to operate with Goose. And the problem is the following. Even if Goose is sustainable to a lot of attacks, we cannot encrypt the traffic because the encryption will add computational processing, which might challenge this time limit, this time restriction. So in a sense, we cannot encrypt it. We have to think of other ways, other methods to solve this problem. One attempt that's currently happening is integrity checking only, just because you can use encrypted tools to check integrity, but not encryption, because it's cheaper computationally to do so. Another similar reason I could refer to is that there are some multi-protocols or situations that you do not need encryption. I can bring an example of the railway system where the signals to change the lines, there is no meaningful meaning to encrypt them, because the existence of the signal can give you the information. If you have these binary situations where we have a switch, so the signal is an on-off situation, you can deduce some information just by looking at the channel itself. So this is the main point with the protocols. But of course, the main problem, I would say, is complexity and additional overhead. To put encryption, you need to expand your infrastructure. You have to implement certificates, PKI, you have to revoke certificates, you have to use revocation lists for that. So you have to do all these steps in a very strict environment, and you have to change all these processes that you had to introduce this new technology to your field. And of course, if you introduce encryption, then you do one thing, you actually encrypt your channel, and this has one backfire effect, which is that you cannot use your cables, your channels, for troubleshooting or for monitoring reasons like threat monitoring. So this is another problem, that you reduce your visibility also to yourself. And currently, a lot of people have in their processing methods to use this visibility to solve problems that you might have in the IT sector.
So it's like adding the encryption is opening up a whole can of worms of another set of problems that we have to solve. It's like solve one problem and then we have to go and solve 2 or 3 more.
Exactly. So this is a discussion that one might have. Do we actually need encryption? Should we implement it or not? For me, it's not a binary question. I can give you not a yes or a no. It's let's have this discussion. Let's tailor to our problems. Just understand where we need encryption, where we don't need encryption, what challenges we have, and how we can solve them. So to move to another point, there are some players that have some first baby steps in encryption. I can refer to, for example, Siemens is using Step 7 Plus protocol in the PLC communication to encrypt some parts of the interaction, like the PLC code or some functionality. There is also Modbus is pushing for a secure version, secure Modbus is called, which is using TLS to encrypt the Modbus protocol and provide, basically with a well-known technology like TLS, the required effects. And in the grid industry, there is standard 62351, as you said, that is an umbrella standard to improve security for other standards like 61850 and 6870, etc., etc. So there are some attempts, and the industry is pushing to that direction to do this kind of stuff. But there is a lot of consideration and there is a lot of skepticism about the complexity and how these things are going to implement it. So you can see basically that they are implementing solutions, but people are not adopting them fast enough, basically for all these challenges that we referenced before.
Absolutely agree. And I've seen that firsthand in the years I've been in the field. I've seen quite a bit of slow adoption for things like Step 7 Plus, simply because the benefits don't really outweigh the added complexity or the need to move forward on that protocol. And I see a lot of it. People are just comfortable with, using what they know, and it's not there's not a major push out in the field right now to get there quickly. So I totally see what you're saying on that point there.
Yeah, it seems like it's something reasonable and something that is happening classically in the OT environment. This kind of changes take time to happen, and the regulators also are reluctant to push for these changes until the technology is mature enough to do that. So the main problem here is that in the IT denial of service or some issue with the certificate, it might be not an issue, but here is a problem, and we will reference some of them. But it's the fear that if I'm going to introduce it, did I just make myself vulnerable to more problems, either from accidents or attackers? And does it worth the security exchange that now I have encrypted my communication? And this is a question that you basically respond to by doing your risk assessment, by analyzing the situation, by seeing what exactly is your need, and implementing the correct solution for your problems.
Right. I mean, if you think about like somebody who may be having to choose, if you have an RTU out there and you only send it 2 commands, on and off, and that's encrypted, does that really help? If you could sort of deduce which command they sent, if it's on and they sent a command, you can pretty much deduce that it's probably an off. And so, yeah, the existence of this, sometimes the message is a giveaway of what you're trying to actually hide behind the encryption. It's a very complex problem, and I'm excited about the details you're about to show us, talk about with us about how this stuff's gonna pan out.
Yeah. So all this creates that scenario. So if we discuss about implementation problems, we can think of some of the solutions. First of all, the problem that I referenced about Goose, it has to do with performance issues and stuff. But the main solution to implement something is to not create more problems that already exist in the scenario. So that will be the possibility, for example, to inspect encrypted traffic. So in that sense, what's proposed is to manage and create your infrastructure in such a way that you, as the asset owner, will still have access to the encrypted communication. So there is a discussion about what will be the scheme that you are going to use, how are you going to implement it, but the basic idea will be that you are not going to lose the visibility that you used to have. So if there is an encrypted channel between 2 PLCs, let's say, you will be able to see the values, but the adversary will be not. So in that sense, you might think of some of how are you going to use this technology to do that. And it's going to have with perhaps a specific setup that you are going to do. For example, you can think of a proxy machine that is going to be between 2 PLCs, and think that this proxy device is going to authenticate twice, once for the one PLC and once for the other, and it's going to pass the communication between the PLCs. Now you might think, okay, this sounds expensive and this sounds like it's introducing overhead in the communication. But the reality is that this kind of solution solves problems depending on your needs. So if you don't have a performance issue, you can implement, there are implementations that are very fast, the encrypting and decrypting stuff, like specialized hardware and FPGAs, that it can provide you exactly that result very, very efficiently. So it might be your scenario that you do not have this case of a problem. Another scenario will be to share the certificates or the keys with your trusted nodes and be able to decrypt the traffic by doing that. So this introduces all the problems that what if I lose the other node? What if someone attacks that node that gets the information? So basically what I'm trying to say is that it's a balance and it's something that you need to identify for your own infrastructure. There's not a simple solution to that. We're pushing, the industry is pushing to find more robust solutions every day, but the idea is that you have to understand what you need and how you're going to implement it, if that makes sense.
Totally, yeah. Right.
So
that's the challenge.
Yeah. Yes, please.
I was saying that is the challenge that these grid operators are facing today, is how do we navigate that, basically.
Yeah, exactly. So the other problem which is introduced is basically that you introduce another aspect of problems is that you introduce attack vectors. And in this sense, again, it's something that you have to understand, I think, is that the PKI has a specific series of new problems that are introduced. The problem here comes that if you install certificates, for example, that expire, apart from the management part, which is a very hard topic and people struggle to manage their certificates, you have the issue of if the attacker is able to expire with an attack that certificate by force. So in an example, you can think that if the clock of the device that is using this kind of certificate is out of sync, let's say 5 years out of sync, then the certificate is invalid and then the communication can be blocked. We saw that example in the experiment we did with the RTU using 62351, the part 3 solution, which part 3 solution is basically encryption using TLS in smart grid. So it's just the classic communication with TLS and with certificates. So what we did is we managed to hack the NTP server. In this scenario, it was just the switch, but the idea is that we changed the clock of the device. And the effect it had is that after the session was closed, it could not be reestablished. So we basically created a DOS state. We could not access the RTU and we could not access our device. Now, if you think that this might be a problem, think that how far these RTU are placed and how difficult it is to approach them and do the changes. So this introduces you the issue that how I'm going to tackle this, how I'm going to have a solution for that. And in a sense, you might have a lot of solutions. You might think, okay, I'm not going to take all the NTP. I'm going to use the GPS. I'm going to coordinate all my information. My device might have a mechanism that says if I see a huge change in the clock, issue an alarm, do something about it. You can have a downgrade in a worst case scenario, which introduces security problems because you lose security, but you don't lose functionality. You don't lose your device whatsoever. So in a sense, you have to reason about now that I implemented this kind of thing, how things can go wrong in that sense. And basically, the clock is one of the ways that you can break stuff in this manner.
Wow, that's actually quite a scary point, because when we go out and talk to customers, or we're looking at security assessments and asset inventories and things, it's very rare that NTP servers or services are really on their radar. I mean, they're usually looking at the PLCs and the DCS systems. They're looking at Pi servers and the HMIs. They're looking at what they consider critical infrastructure, and a lot of times these types of things kind of get thrown over the fence to the IT side, or they're sort of not really paid attention to as much as some of the other parts of the infrastructure. So it's amazing that that is a weak point, and that somebody could lose control of their entire encrypted infrastructure simply by attacking an NTP server.
Yeah, so the problem here arises exactly to the choices you made. It might be not the most rational choice to choose to put this kind of infrastructure in that way, but you're absolutely right. It creates a new problem that you might not expect. Maybe your process is robust and gets this kind of time changes because you don't need this kind of accuracy or you don't care, so you have mechanisms for that. But that way you can lose some of the visibility exactly because you try to be more secure. So another scenario would be I hack a system or have access to a system that needs to authenticate, which is on the other side, not the RTU, but the workstation, and I managed to remove something there, delete the certificate and stuff like that. Of course, if you have this kind of access, you can argue that I have a lot bunch of other problems. But the thing is, again, the issue is if you remove your visibility, if you remove the clock, if you touch something like that, if you remove the certificate, what is your strategy? What is your plan in case you do that? And these are things that people can think of. Another thing we tried was to install our own certificate, a ROC one. So the idea on that scenario was that perhaps a malicious insider that had physical access to the RTU or in some method that is not detectable, that was the point of that, was able to install his own certificate in the device. And the concept was that after that, he has access to everything in the related device. So then you have to think how I'm going to be sure that only my certificates are in there, are validated, how I'm going to check them. Is there a way to have a response back as to how many certificates are in there and how things are expiring? All these mechanisms exist, but you have to put everything again in order and decide what is your need, what you need to do, how you're going to approach this problem.
Yeah, a lot of the like PKI infrastructure is really IT centric, and it's rare that that bubbles over really well into the OT side, and you have the plant engineers on board with all the necessary processes and security around keeping PKI safe and operationally secure at the same time using it properly out in the field. It's and then being able to, like you just said, manage certificates on PLCs is not very easy to do.
Yeah, it's not. So we can discuss about the argument here. Is it good to introduce that? Is not. My opinion is that it's just well, as a security expert, I can advocate yes encryption, yes security, but I understand the problems that are created, and I'm just saying that we are putting on the table the discussion that has to be done. That is, you have to create everything according to what you need to do, according to what are your needs. And you have to also understand what are the dangers if you do not do that. I mentioned previously Goose, and I said that you cannot put encryption. And it's proven that Goose is a problematic protocol because you can do injections that I can give commands, etc. So it's a situation when we would like to solve. And there is already discussion about implementing an extension that is going to just use cryptographic tools to implement integrity and authenticity. So at least you can avoid the computational problem and can verify that at least the information I'm getting is the correct one. No one is replaying attacks. No one is injecting stuff. So that's a good scenario that says, okay, I had a problem. It was technically difficult to handle and understand and find a correct solution, but I had to do it because the industry has problems. So
Right.
it seems like everyone is pushing for that direction. Everyone's pushing for managing these issues, providing solutions, and perhaps also the regulators at some point will come and say, hey, so if you want to be safe, if you want to approve you have to embrace some of these technologies.
Yes, which pretty apparent in what we're seeing, and what we're talking about today with the IECs out there that are overlapping, and the 61850 that doesn't really have much in there, and then today I think we're going to talk a little bit about the 62351 that is specifically about what you're talking about, the encryption for these devices.
Yeah, so the concept of 62351 is basically, so it comes back to 61850 and some other standards that have to do with the energy sector. And so what's the idea here? The idea is to improve the security by adding all these features that were missing from the previous protocol. So I referenced that we did a test with an RTU. And in that scenario, we used the standard 62351 part 3, which implemented the encryption in TLS. So in the specific scenario, we had specific configurations that is going to be the XYZ TLS version, and the consequence is that we need to have a decrypted channel and not integrity only. So we just wanted to see how this is going to be implemented, and it was quite straightforward. It was similar with TLS. We have to have just the certificates and everything else. But we have the problem that if we put the device out of order, then the device, if we remove the certificate or we move the time, then we had a problem with the device. The device was not operational. Other parts like 6351 part 6 have to do with Goose, and it's the introduction that I referenced to the integrity only, basically the HMAC function, which produces a hash for each message that is sent from the network. And the idea is here that you are able to verify and identify that this is the case. Other parts like part 7 introduce queries that you can ask the device, questions that are part of your implementation. They don't have to do with encryption, but you can ask things related to the certificate. So you have a mechanism to ask the device which are your public keys, which is your revocation list, which are your certificates, where they expire, and so on and so forth. So you can use that to have communication with the RTU and get information as you need it. And we saw that it's quite effective to have this information and test it and get your own. So an idea was the device has the certificate. I have the public keys of those certificates installed in my IDS device, and then I can correlate and see, okay, are those public keys true? Is there a problem with them? Should I go there and do an on how to say? So basically, the whole standard approaches all these problems in an umbrella solution about how we can improve security in the standards. It introduces some complexity, and perhaps this is the argument that it's difficult to implement the stuff. But I can see that in action, the discussion is more and more to the positive side of maybe we should think about implementing these kind of solutions.
Yeah, absolutely. It seems like a logical step to increasing cyber resiliency on all fronts, especially our grid. And we're just going to become more and more reliant on this stuff. And this seems like a good way to bake the security in from the beginning rather than bolting it on later, and at least some security. Yeah, it's very interesting how all the different regulations are overlapping, and you really have to be an expert to navigate which ones are on top of which other ones and how they relate and how to get this equipment deployed and build this grid in a way that navigates all of that and keeps them up and allows them to maintain control if something happens. So what kind of backup plans have you seen folks using out there if, let's say, someone does attack a system and is able to lock up their certs? What do you see, or what do you recommend folks do out there as far as having like a plan B? What can they do if something, or how can they plan for that?
So yeah, there is in my reasoning, you have to understand you have to know very well what your process is managed to do and what it should not do. So if if you lose communication, if that's a huge problem, how you can be outside the situation. And I referenced before that you can have a system like secondary communication channels. You can use other protocols to coordinate time like GPS or etc. You can have alternative methods to contact the RTU, perhaps without encryption if that is necessary to save the day. But you have to understand also which is the level of intrusion to reach this result. So if a hacker has access to the RTU and manages to get the certificate, it probably has root privileges or something like that in the device. So then it's a whole different scenario as to how can I trust everything else? What can I actually do? Maybe the device is lost forever. If you think about the problem with NTP, the previous suggestions are going to work. Other suggestions would be to maybe consider, it depends on how much the problem with encryption comes, that maybe you should consider using non-encrypting protocols. If that's the case, integrity-only protocols, that's also a discussion. So you lower your security level a bit, but you gain the benefit that you don't have to make all these drastic changes, or you don't have to worry about the content. Again, it's difficult to say a specific solution like this is what you have to do. You have to understand. So it's basically a threat modeling and a risk management process. You have to understand what can go wrong, how expensive it's going to be to fix that, and decide that solution in that place.
Yeah, agreed. And something very early on that could be done that's cheap and yet highly effective is consider what the attacker is going to do if they get in and they come across an encrypted protocol and they want to get into that. They're probably not going to go over the IT wall and start attacking the PKI system. They're going to go for the easiest, lowest hanging fruit, the weakest link, and that's going to be probably the engineers or the people that have email on their laptops that have the keys that they need. So they're going to move lateral and they're going to start looking for other ways to get access to those keys that you might not anticipate. So making sure that the out of bounds methods are being leveraged to exchange those keys, I think is very important. So you don't want to email them to the engineers. You want to probably give it to them on a USB and allow them to walk it into the plant, put it on the device, and then destroy the key later. That way, if the hackers do get in, they have a little bit more of a challenge getting access to these protocols or disrupting the environment.
Yeah, you make a great point, because the problem here is how do you manage your certificates and your keys? And of course, if you move keys around in emails, there is already a problem right there, right? That you have to have a robust security policy. How are you going to use secure devices to transfer them? How are you going to train? Because training is huge, is very important in this kind of situations, to train your engineers how they're going to use them. And this is basically what's going to prepare for the worst. Of course, if we open emails and we are victims of phishing attacks in that way, and then the workstation is compromised, then I don't know if even the certificate is the biggest issue. Then everything is open. Everything is on the table. You can lose maybe not the certificate, you can lose the device. Someone can upload code and do whatever. So that's a very good point.
Especially if those certificates are being used for authentication, then somebody gets one email account and boom, they've got the entire infrastructure. So yeah,
those scenarios are very dramatic, but yeah, if that happens, it's a very huge problem for the whole infrastructure. That's why I think maybe the biggest problem in the discussion we have is how you manage all that. So even if you implement it, if the problem perhaps is not the implementation, but how you manage all that, and how you do not more attack vectors to your infrastructure. So I said before that in the scenario when you want to decrypt, you have to use proxies. Let's say it's an example. Then you have to add another device, a physical thing that is going to be connected between the two PLCs. So it's another IP, another asset, another target for someone. So you have to take care of all the same problems that you had before. You have to understand what's happening if that device goes down. What's happening? I'm losing two PLCs speaking together. I have to have a strategy for that also. So if you think about it, it's kind of a headache to reason about this stuff. But this is what we are doing. This is what we are pushing for. We are pushing to understand what is the best system, what is the best solution, of course, to the problem. So what is your need? What do you need? Maybe your protocol does not need encryption. Maybe it does not need authentication. You have to put everything down, understand exactly the problem, and provide a solution for that.
Totally agree. Yeah. Even within the word encryption, there's differences. Like on the IT side, if you're just slicing and dicing up encryption, you'd find that there are some protocols that are great for high-speed, one-directional traffic. Other ones are great for bidirectional. something I'm sure a lot of IT, especially cybersecurity guys, are thinking about right now is, what about like Diffie-Hellman that has dynamic key exchanges? And when they're coming from the PKI infrastructure over to the OT world and they're bringing this technology with them, how does stuff like that fit into this?
Yeah, so let me have a small explanation about how this is working. So if you encrypt, so if I contact Google right now, I have encrypted communication, and this encrypted communication uses three tools. The first is public encryption with the certificate. The second tool is the Diffie-Hellman key exchange algorithm, so it's the way to exchange keys.
Mhm.
And the third tool is symmetric encryption. So it sounds complicated, but it's not too much. You can actually do the same thing with just one tool, the public key encryption. The problem in the scenario is that it's very slow. So you have to add the second tool, which is let's exchange keys, but do the actual encryption with symmetric because it's 1,000 times more faster. And the third thing is the Diffie-Hellman you mentioned. The problem with the Diffie-Hellman is it proposes a method for two assets to exchange keys without any knowledge about them. So it actually doesn't help for authentication, but it helps so you are able to use the symmetric algorithm to have the same encrypted channel. So you need also the public infrastructure for authenticating. So the problem is certificates can move around, but this method that is generating between two PLCs does not move around. How do you arrange this issue? And unfortunately, you cannot break the system. The idea here is you go back to the design approaches that you have, and you reason about how I want to approach this problem. To give you an example, so the problem with if you use the certificate is the following. If I record your traffic, so I'm not using Diffie-Hellman, I'm using only the first two tools. If I am recording your encrypted traffic, and somehow I manage to get your certificate, then I have all the knowledge. I can decrypt your traffic, I can read everything. So the problem is, let's use the session keys to avoid that. But now the session keys create the other problem. I cannot share them. It's very difficult
Right.
to share them. How we can solve this? So the idea is, first of all, maybe you do not care about if in the future someone can see the traffic. So if it's an operational thing, like values of temperatures moving around, maybe it's important for you if now no one sees the traffic, but it's not important for you if in the future someone's going to see the traffic.
Right.
So in this sense, you can choose another cryptographic tool only with the two tools that I referenced before, asymmetric and symmetric encryption, and totally avoid the Hellman situation. But if you have to do that way, then you have to think out of the box and think, okay, let's introduce a system that is going to share the keys. So maybe I have an asset that's communicating with two PLCs, and I'm getting the key for them. This problem can be solved with a proxy solution, but if you want to avoid that for reasons, you can just have this new infrastructure that you're going to share the keys. So if you have the session keys, you can decrypt the traffic and do the same thing. Again, comes to what exactly is your requirement for your system. You have to understand what is happening and what I need to be secure. If you need to have session keys to have this extra bit of security for the future, I want to upload PLC code. I don't want anyone to record the traffic and in the future see something. If I lose a certificate, great, go with a session key, but implement the infrastructure that is required to look for the key. Use a proxy machine, use a machine that collects the session keys, find another method. There are some methods proposals that solve this problem in that way.
Great. Yeah. I've seen that come up once before, and I know we talked about it a while ago, the complexities around that. And yeah, thank you for that. Do you think there's anything coming up in the future that's going to impact all this stuff? Like, we're talking about Goose and these IECs. Do you think there's anything outside of that that's going to impact all this stuff? Any new protocols that you feel are taking off or that are going to?
I think the main thing is coming in secure Modbus. I think currently it's implemented. It's going to be up next year at some point from vendors. I mean, it's already come from the standard process and stuff. I'm not aware for any other attempts that have a solid ground at the moment, but I'm sure there are out there doing the work. I think the main issue here is integration. what is the motive to put this kind of stuff in your infrastructure, and how important is that. My opinion is that it will come at some point where it's going to be mature enough for these technologies to be integrated. I can assume it's going to be in the next 5 to 10 years, but I'm not sure, of course. And it's going to be, in my understanding, perhaps mandatory to have this kind of systems. Because right now the field is kind of blurry of what are the problems and what are the solutions. For sure, you have problems with confidentiality and encrypted traffic. For sure, replay attacks, integrity, and authenticity are other problems that we have to solve. And in my understanding, at least for the new protocols that are going to be out there in the next decade, they will have more security features than those that were deployed in the previous decade or something like this.
So this problem's here to stay. In other words, it's not going anywhere. We should be seeing more.
I do not think it's not going away for sure. It's the thing is not already here is because it's quite complex and challenging because everything likes one solution for everything. Just do it and leave me alone. And I understand that's the case, but I think. And basically what is happening right now is they try to tackle this. So they try to create protocols that are going to handle all the situations. Siemens didn't have encryption in their protocols. They added it with a new protocol. So the reasoning is the same. At least let's halfway solve the problem. Let's not decrypt everything, but let's encrypt the PLC code, or let's encrypt this, or let's provide integrity to that. So attacks are manifesting in the real world. We have seen power grids falling around. We have seen other attacks happening. So it seems like it's going to be a requirement from my perspective. Maybe not in the near future, but in the immediate future, it will.
Yeah, I probably don't disagree with that at all. I think it's going in the same direction as well. We saw IT go there years ago. It only makes sense that things are going to happen everywhere else as well. So I would agree with that. So what do you think our product, I do have a question here coming in from QA, and I think it leads us into another area. So if someone has our product in their facility and they're suffering through these attack scenarios that we talked about, where do you think we fit into this equation, and what can Nozomi Networks Guardian bring to the table in terms of detecting or helping to identify and harden the target?
Yes, we tested that, and we created a scenario that we can defend and guess the two scenarios that I referenced, which was the NTP attack and the ROC certificate installation. So it's the nature of the problem that you cannot do this passively. So you cannot see the public key transmitted correctly in the time you need it to verify the scenario, because all the operations come internally when the certificates come in place. So in our solution, we use the 62351 part 7, which allows you to query devices, of course, that support this protocol, that will give you information for the asset you want to protect. So the queries we created using this standard was, give me your time, give me your clock, let's say. So this is a very easy information to get from a system. And the idea is that after you get the clock, you correlate with some tactics. Will be you correlate with your own NTP time, but because that might be off if the whole infrastructure is attacked, you correlate also with a local time that it's static for you. It doesn't change a lot. It changes after a few minutes. So if you see a huge delta, if you see a huge difference in time, you raise an alarm. It's like we set the time for a few minutes, but you can set it for whatever period you want. And the idea is that we change the certificate 2 years in the future, and we were able to produce an alert that says, hey, there is a problem. This device has a huge delta in time. It might be that the communication is going to be problematic if it uses certificates, etc. For the other problem with the certificate that it started, we had the mechanism that we were querying the device, the certificate that it had, the public keys actually. and we will validate. So it assumed that we had the list of those certificates installed in our product. So the idea is correlate with the certificates that exist in the product and what I have in the RTU. And if there is a difference there, a public key is not the same, a new public key appeared, something is off, raise an alert because the engineer didn't update the system. So it's it's a monitoring system. So everything that's different from what we monitor should be reported. So that's the idea. So those were the solutions. They needed the active approach here to do these queries because it's the nature of the system. Of course, you can wait for passive traffic to maybe hint this information, but it might be it's not timed correctly. So if the time is not maybe sent the time you need to know that information, or the certificate is installed and you never know that it's installed because no one used that communication channel. Of course, if it uses, you might see a whole other factors like new IPs, etc. But that is how we approach this problem.
Yeah, that makes a lot of sense. So we would raise multiple alerts for the attack itself. And additionally, we would also probably even see the initial intrusion depending on how they came in. And then after they ran into encrypted streams and they wanted to try to hunt down those certificates or attack other things or move lateral, we would see all of that as well. I mean, there would be a long trail of alerts being left behind for all the actions that we've talked about today. So there would be no shortage of ways to detect these types of attacks. We are getting a little bit low on time, so how about we move on to QA? Giannis, do you have anything else that you wanted to make sure we covered before we go to our live QA?
We can move to the QA. I think we are covering the topic.
Wonderful. Okay, so our first question from, and I'm sorry if I'm mispronouncing this, Seco, says, are you able to provide a solution for Goose and SV?
So if the question comes for detecting attacks on Goose, we already do that. So in a sense, we have managed the attack scenario on Goose, which is the injections, etc. I think we have done something similar to SV. I have to check. The idea here for Goose is that we will able to navigate through the most of the attacks that happen out there, if not all of them that are public known, and we try to do some of our own for testing purposes. If that is for the attack scenarios that can happen with Goose. For the encryption thematic here, we are planning to. So Goose doesn't have encryption, but they are going to add an additional header in the protocol, an extension that's going to provide the integrity checking with HMAC. And we're planning to be able to provide the key to the product, so we can not only the device, but also our product can verify that indeed this packet is authenticated, etc., etc. So something is to be done, but the attacks are already covered.
Excellent. Okay, the next question, I believe we just covered it, which was what can Nozomi do to help identify these attacks. So I'll move on to next is from Melvin. What about the insider threat, even if you have encrypted communications?
Yeah, so the problem with the insider is a huge issue, and the problem here is that it depends of the access that the insider has. If it's your head of security that's the insider, there is no solution here, right? He knows the tricks, he knows the password. Done. You cannot win. I think that it's quite challenging to tackle this issue. I would say that you need to have checking mechanisms against all the players in a company. So you have to have policies. You have to have. You cannot tax. So if you have a CA certificate, if you have an authority to issue certificates, then you should apply specific policies to when you can sign something, which people have to be there to do that, maybe timers to access. I mean, all things are concepts that are quite hard to implement, but that's the issue. Implement as much checks as possible. The other thing is policies that you have agreed on, and you have to put check mechanisms on them. which is going to be when someone is able to access certificate, install, and revoke them. And that could be in a sense that maybe you have checking mechanisms if a legitimate login process is going to change something, but it's not the day to do that. We have another policy that says at this point of time, we're going to do that. So in a sense, it's difficult to tackle because people from the inside should have privileges and accesses. So the main thing, which is the classic comes from the IT world, is to create the correct privilege access that you need. Always have more than 2 people in key points. You cannot have one guy be, I don't know, your IT guy and everything is on his hands and the password, etc. And then if he goes rogue or something, you lose everything. That's not how it should work. You should have proper backup policies for everything. So at least if someone removes stuff or deletes stuff, you have protected backup that you can recover. But this is good, cybersecurity hygiene, generally speaking, from the IT industry. Also, you have to have the correct policies to avoid that. I would say keep in mind to have the credentials in a good quality of credential management among the users, and be able to revoke privileges very easily if something goes off or suspicious goes off.
Right. I might also add, I know that one of our tenets in cybersecurity is trust but verify. But in this case, I kind of lean towards the zero trust model. You don't trust any device. You might have managed devices, but you shouldn't trust them. Monitor everything. Treat everything on this network as if it could be hostile and in the hands of someone other than the person in front of you. So if you start your security like that, then eventually you'll find it's much easier to mitigate insider threats because you don't have all these holes of monitoring and things that they can do without being monitored and outside of policy, where that creates these areas where these attackers can operate and insiders can do things that are bad and you won't catch it. So zero trust is important. Monitor everything in there and everything it does. Look for the anomalies. Look for things that are like breaking the protocol. Look for things that just aren't right. And many times you'll be able to help identify some of the early actions of an insider threat before they actually do something damaging in many cases.
Yeah, it makes total sense.
Yep. So our next question here is, what about intended OSI Pi, historian related, not real-time ICS encrypted protocols? So OSI Pi has some encrypted protocols that are not real-time ICS. They are more about data. I think they're more about data at rest and encrypting things to the historian. Do you have any thoughts about that?
Sure. So yeah, I mentioned that there is this kind of technology in the upper SCADA level. So historians have the solution for encryption, and this kind of technology uses the classic IT approach with TLS and certificates, etc. But the difference is that you don't care there because it is a backup process. And as a historian records what's happening in your traffic. You are more flexible in a sense of timing and error factors, etc. You are not worried. You are worried, of course, if the historian has a problem, but you are more worried if your PLC dies or lost a connection or something like that, because that will affect the operational process. So that's why, because you're not worried, there the technology is used normally. So it's a classic, we go to the classic IT solutions that are already in place. So then you do your management, your PKI, etc. The difference is basically how you do the same thing on the lowest levels with all these problems that we discussed and with the distances that we discuss and all these other factors that go inside. The historian might be in a very convenient place, easy to reach, easy to maintenance. And the RTU can be in the middle of the desert. You cannot reach it, do anything. So it's a different problem. So as you go upper, you go more to the IT, and there are already there are some answers there that are used. If you go lower, you see that there is some more problematic situations that you have to manage.
Yeah, something that some people forget or don't know about these power grids is that they could be spread out over thousands of miles, and you could have 10,000 of these RTUs out there flipping the power grid on and off. Anybody who's ever rolled out encryption in IT before ask them to think back to their project. And now, can you do that remotely without actually having the equipment in front of you? Can you roll out enterprise encryption? It's very difficult. And yeah, it's a daunting task for many. And it's been a lot of really good details that you provided around that. Eduardo has a question here. What is the approximate delay introduced by hardware versus software encryption? I think he's asking which one's hardware encryption is going to be faster, but what is the difference between the two? And could it be a bottleneck protocols faster than Goose, like sampled values?
Yeah, I'm not exactly sure about the metrics because I have to work with a FPGA with a long time. I would say for symmetric, it should be a good solid difference. If you I think at this point, an FPGA can make the encryption process specifically symmetric, which is what we are clear about, almost negligible. I cannot provide the number right now, but I will have a look and provide the number after this webinar. But it should be, I don't know, less in the order of microseconds, I suppose. In the design that I did, I was working on, the speed was like 120 megahertz per encryption, per packet encryption. So it was a huge difference compared to classic software. Because in classic software, you have the common general type CPU that is using the encryption. And again, IS and other symmetric algorithms are very fast. But if you go to ASCII and specialized FPGAs and stuff, you can reach totally convenient speeds that they're not going to hinder the problem.
Yeah,
but I will check the numbers and I will provide them. I'm not sure right now.
Cool. Yeah, and you know, those SSL decryptor cards, they've been around for a long time too, and they're pretty cheap, and man, they can blast through some encryption pretty fast. We're running a little extra low on time now, so let's hop down to our question. We have a couple more here. Let's try to get both of these in if we could. So from Eduardo, securing the network with a whitelist technology, forwarding traffic only to the ports where they are supposed to, like relays in the IDS, seems to be a solution to provide confidentiality to a LAN. Can you share your thoughts about that? So using securing the network with whitelisting and forwarding only to the ports where they're supposed to, like relays. What do you think about that?
As I hear the question, I think that whitelisting means whitelisting IPs or what. So if you whitelist assets and nodes, I think the problem to eavesdropping is not is if you have even physical access or you have an interceptor that can lose the traffic and hear the traffic. So if I can see the traffic somehow, even with a tap, even with an interceptor, an antenna or something, think of the RTU, that the communication is remote, is wireless communication like GPS or whatever. If I go next to the RTU, maybe there is a fence, but I can go next to it, and I use some device to catch the signal. Then there's no way. Well, the thing is that you lose confidentiality because then I can see the traffic, etc. So that's not an issue there. But of course, whitelisting is a good practice to avoid other problems like new nodes, new players with new certificates, etc. And of course, it's a way. As in the asset perspective, if there's a new IP, if the certificate perspective, is there a new public key that you don't know about it? Of course, this solves the problem, for example, for the rogue certificate, that if you have a whitelist and say, okay, these are mine, do not accept anything else is going to work. But of course, you can spoof stuff in the IP. You can use the same IP and the same MAC. I mean, it's digital information. You can write whatever you want. And this is not going to save the day. For example, Goose is on layer 2, so no ports, and it's just a MAC address. So literally, you can just use, you can create the same MAC address as the node if even there is a check for the MAC address from the electrical device perspective. And you can do a Goose injection without any of these things. You can just block the power if you just have the way to send your signal in the traffic that you have to send it.
Yeah, there's not a lot of whitelist opportunity there when it's just based on the MAC. Yeah.
Yeah, you can. Well, even in Goose, even if you whitelisted by the MAC, you still have a problem because the attacker has to use your MAC to make the attack happen. So what we did for Goose was we put a laptop, we created the same MAC, and we set an injection command, and we managed to switch off our PLC, our ID PLC. So it was really simple to happen, and it solves the problem that you need, because exactly it's in layer 2 and you have nothing else, no TCP IP, no TLS, nothing there. You need to address this with another way. So this is why they do the extension right now.
Yes, yes. Okay, well, it looks like we're out of time. So Giannis, I wanted to thank you for your time today, and we appreciate all the research that you and your team do on the back end to keep us full of information up here. And we have some of the valuable stuff that you guys have put out available here on the screen. It's pretty often that we have some exciting new content coming out from our Nozomi Networks Labs group, and here are some links to some other things, blogs, some case studies. I do recommend checking out the case study on NL. I think that one's pretty relevant. Also, one of our co-founders did a really good one on the IEC stuff and Goose. Is there anything here that you wanted to highlight or close out with, Giannis?
Yeah, as you referenced the last point, which is the IC and Goose, this is the new implementation that they're going to do, and it's something that we also going to integrate in Guardian. So we're able to verify if the Goose packet that's going to set using that extension, it's actually valid. So it's exactly how a current problem is going to be solved and how we're going to follow up with our approach to monitor it, etc. So it's a good log.
Excellent. Thank you for that, everyone.
Thanks for everything. It was a
NTP Networks, stay safe, stay secure, and we hope to see you at our next webcast. Thank you very much for your time.
Thanks, everyone. Thanks a lot.